Today we're going to look at an example of taking a function. Here we have f of x equals x squared minus 2. And we're going to find the average rate of change on our interval, -2 to 1. Then we're going to find the equation of a secant line containing -2 and the function of -2 and 1 and the function of 1. Okay, so on our interval here, we're going to have to take these two values and actually evaluate them in our function to get those results here before we can find the equation of the line or before we can find the average rate of change. Okay, so let's start with part A, the average rate of change. And when we're finding the average rate of change algebraically, we have a formula, delta y over delta x equals the function of b minus the function of a divided by b minus a. Okay, so a here is where we're starting, and we're starting at -2. And b here is where we're ending, and we're ending here at 1. Okay, here, delta y over delta x, this means the change in y over the change in x. And that's what we're doing here. F of b and f of a are y values after we evaluate in our function, and b and a are just our x values that we're plugging into our function. Okay, so here, a equals -2, and f of a equals f of -2. So we need to take -2 and plug it into our function. So -2 squared minus 2, that gives me +4 minus 2, which just equals 2. So I have here -2, 2 as a point. Now I need to find f of b. And f of b here is the function of 1. So plugging 1 into my equation, I have 1 squared minus 2. That equals 1 minus 2. And my answer here is -1. So I have another point here. 1, -1. Okay. So now that I know a and b, excuse me, let me write here b equals 1. Now that I know a and b, and I have f of a and f of b, I can plug in everything into this equation here, and I'll have my delta y over delta x, or my average rate of change. Okay. So the function of b we found to be -1, so delta y over delta x equals -1 minus the function of a. The function of a here is +2, and divided that, we have b minus a. B here is 1, minus a is minus a -2. Okay, let's simplify this down. I don't need the set of parentheses here, so I can just have -1 minus 2. And here, I have two negative signs, and double negative property tells me that that's really addition. So 1 plus 2. Simplifying further, I have -1 minus 2. That is -3. 1 plus 2 is 3. So the final result is -1. So delta y, delta x equals -1. Okay, this is my slope of the secant line. Okay. Now I used my points that were given to me. I had a and b. I found f of a and f of b. So I have these 2 points now. So I can use them to get my equation with using this as my slope. Okay. So part B here is the equation of the secant line. Okay. So we have a formula for finding the equation of a line given a set of points, and that is y minus y1 equals the slope of the secant line, x minus x1 in parentheses. Okay. Now, we have two sets of points here. We have -2 and +2, and we have 1 and -1. Okay, these were the results from our previous page when we were evaluating. And it does not matter which set of points you pick to plug into this formula. Okay, we used both of these points to get our slope. They're both contained in the line. So we can pick one. And we can pick whichever one is easiest to use. Okay. So let's do y minus, we're going to start with this one. Let's do this one. y1 here then would be +2 equals, my slope we found was -1, and we're multiplying that to x minus x1, and x1 here would be -2, so I have minus a -2. Okay, let's simplify that down a little bit more. We've got y minus 2 equals negative. I don't have to write the 1 anymore, it's understood. X, double negative property here says this changes to addition 2. Okay. The next thing I want to do is distribute this negative sign across my parentheses. So I have y minus 2 equals -x minus 2. And finally, I want to solve for y. Solving for y means I need to add 2 to both sides. This adds up to 0, and this adds up to 0. So I'm left with the equation y equals -x. Okay, so this would be my answer for part B. For my own benefit, let's do this one more time. But let's use the other set of points that we had, just so you can see that no matter which set you pick, you're going to end up with the same equation. Okay, so our equation for a line we said y minus y1 equals our slope of the secant line times x minus x1. So this time, let's use the points 1 and -1. Our slope here was -1. So let's plug in this set of points to find this equation, okay? So here I've got y minus, y1 here is -1, equals my slope from part A, which we found to be -1, times x minus x1 here is just +1. Okay. Now I can simplify. Double negative here tells me I can change this to addition, so I've got y plus 1 equals, on the right hand side I have this -1 that I need to distribute across my parentheses. So -x plus 1. And now I need to solve for y. Solving for y means I subtract 1 from both sides to get y all by itself. This adds up to 0, this adds up to 0, and I'm left with y equals -x. Okay? So even though the instructions tell you to find the equation of the line containing 2 points, when you're actually finding that equation, you only need to pick one of them. Okay? Here I ended up with y equals -x, and when I used the other set of points, -2, +2, I still ended up with y equals negative x. Okay, so it is your choice on which set of points to evaluate in this portion, and I would choose whichever numbers looked easiest. If they were smaller, maybe not fractions, it's up to you. And now we are done.